Welcome to Calibration Measurement Process Descriptions, and thank you for your interest. We hope you'll take time after this short presentation to explore the other Triad Unlimited presentations on YouTube, follow us on LinkedIn, and visit our website to see all our services and training offerings. Calibration measurement defines the rules for measuring and test equipment specifications, traceability, certification, and storage. Calibration measurement makes sure that we have the right measuring and test equipment for our processes in terms of accuracy and other technical specifications. We make sure that the MTE is traceable to an appropriate standard and prove that our MTE meets all necessary certifications and conformance requirements, and then make sure that we take care of our MTE by storing it properly. Like all AMP functions, there are four processes associated with calibration measurement. First is measuring and test equipment specifications, then measuring and test equipment traceability, measuring and test equipment certification, and measuring and test equipment storage. There are several benefits associated with calibration measurement. MTE specifications allow detection and control of every parameter of interest with the accuracy and precision necessary to ensure product of the correct quality, purity, and strength is consistently produced. Traceable calibration always helps to improve process control and research by ensuring measurements and resulting data are correct. Equipment certification ensures instrument accuracy and precision is commensurate with MTE specifications. And establishing storage protocols for standards limits degradation due to environmental conditions and reduces the chance of measurement error. Measuring and test equipment, or MTE specifications methodology, creates rules for measuring and test equipment accuracy and accuracy ratios. Process parameters have tolerances. Maybe the temperature of a certain process must always be between 90 and 100 degrees, or the process must be shut down. Another way to say that is the process should be 95 plus or minus 5 degrees. Since not meeting this parameter will shut us down, we want to be certain we can control the process within this range. If a temperature control loop is used that has a tolerance of 0.1 degree and we set it to control at 95 degrees, it's obvious that the instrument is suitable to keep temperature where we want it. We expect the process to be controlled between 94.9 and 95.1 degrees. However, an instrument is installed in the process that has a tolerance of plus or minus 5 degrees, and we set it at 95 degrees. We could easily be within our instrument tolerance of between 90 and 100 degrees and constantly be challenging the process limits anyway. For whatever processes we can talk about, regardless of industry, instrumentation must be designed with all process parameters in mind and how tight the parameter tolerances are in operation. Likewise, the MTE used to calibrate the instruments must be selected with full knowledge of process parameters and tolerances. The calibration program must contain a process to ensure that the correct MTE is used to calibrate process instrumentation. The intent is to be able to detect and control every parameter of interest with the accuracy and precision necessary to ensure a product of the correct quality, purity, and strength is consistently produced. MTE traceability methodology creates guidelines for how local measuring and test equipment can be traced to governing standards. This ensures that process instrumentation can be calibrated using a local standard proven to be linked to the most accurate standard available. Just as the assets we buy must have the initial capability to meet our performance requirements, so must our MTE be capable of measuring what we need measured with an acceptable degree of accuracy and confidence. Every MTE we use to calibrate or test our process instrumentation must be linked to a tangible accepted standard and pedigreed with documentation attesting to that. The term measurement traceability is used to refer to an unbroken chain of comparisons relating an instrument's measurements to a known standard. Calibration to a traceable standard can be used to determine an instrument's bias, precision, and accuracy. It may also be used to show a chain of custody, from current interpretation of evidence to the actual evidence in a legal context or history of handling of any information. As with other topics associated with calibration, many technical requirements have been developed for managing and ensuring calibration traceability. To mention a few requirements, consideration must be given to calibration accuracy, calibration uncertainty, calibration interval, and the methods used to ensure that traceability stays intact in the calibration program. MTE certification methodology creates guidelines for how local MTE meets certification and conformance requirements. MTE certification means the MTE meets the requirements stated in the program governance documents, often called a quality control manual. The requirements may vary, but the following are typically required of a certified MTE. It must be fit for purpose for the measurements to be made by it and the accuracy required. It must be traceable to a nationally recognized standard and calibrated to those standards on a regular basis. It should be marked with a suitable indicator or approved identification record that shows calibration status. Calibration records are maintained and stored in a manner that preserves accuracy and fitness for use. And instrumentation is safeguarded from adjustments that would invalidate the calibration. MTE storage methodology establishes controlled storage requirements for measuring and test equipment. It ensures that MTE is stored in a manner that will not adversely affect the MTE capability. Measurement equipment isn't cheap and is relatively fragile when it comes to being dropped, exposed to uncontrolled environments, or otherwise damaged. The calibration program must include a way to ensure that MTE is protected and remains fit for purpose. Some common features of a compliant calibration program storage process include: standards are stored in a standards lab, environmental conditions which could affect MTE are identified and controlled, temperature and humidity records are controlled and stored, and any suspect or defective standard or MTE shall be taken out of service, clearly identified, and quarantined. Here's a summary of calibration measurement. Quality management systems call for an effective metrology system, which includes formal, periodic, and documented calibration of all measuring instruments. Calibration to a traceable standard can be used to determine an instrument's bias, precision, and accuracy. The accuracy of an instrument is the measure of the capability of the instrument to faithfully indicate the value of the measured signal. And standard storage must be controlled by documented processes that protect standard certification. This concludes the calibration measurement process descriptions presentation. Thank you for your participation.